This video is for the students of Infinitesimal Calculus 1. Recall the definition that you saw in class for least upper bound. M is the supremum of A, or the least upper bound of A, if it is an upper bound. It is greater or equal than every element in the set, and it is least. It is less than or equal to every other upper bound. We also saw the epsilon property that says that M is a supremum of A if and only if for every epsilon there exists an element in the set that is greater than n minus epsilon. In other words, if we go from the point M to the left a step in the size of epsilon, we will find there for sure in this step an element in the set. This is the epsilon property. We'll use this to prove the following statement. First, we'll define what it means to be a sum of two sets. A sum of two sets is a set which its elements are sum of element from the first set and element from the second set. Or in other words, the set of all the elements of the form A plus B such that A in A and B is in B. Now let's prove that if A and B are non-empty and bounded from above, then A plus B is bounded from above, and the supremum of A plus B is equal to the supremum of A plus the supremum of B. Actually, we already saw the theorem that states that every bounded from above set has a supremum, so we know that there exists a supremum, but we need to prove that also the set of the sum is bounded and that the supremum of the sum is the sum of the supremums. Let's call the supremum of A SA and the supremum of B SB. Actually, now we want to see that SA plus SB is the supremum of A plus B. In other words, using the epsilon property, we want to see that if we go even one step of size epsilon to the left, we will find in between an element of A plus B. But how an element of A plus B looks like, an element of A plus B is always a sum of an element of A and an element of B. Now, it is clear for us intuitively that A plus B has to be bounded, and actually that SA plus SB is an upper bound of A plus B. Why? Because if A is less than SA, because SA is the supremum of A, and B is less than SB, then A plus B is less than or equal to SA plus SB. But actually, if we prove the epsilon property, we don't even need to prove that the set is bounded, because from the epsilon property, we get for free both the fact it is bounded and the fact this is the least upper bound, not only an upper bound. So let epsilon be a greater than 0 number. By the epsilon property for A, because we already know that A is bounded and its least upper bound is SA, so by using the epsilon property for A and taking a specific epsilon, which is epsilon divided by 2, if our epsilon is the epsilon that we want to use for the set A plus B, then for the set A we'll take half of it. We have, by the definition of the epsilon property, that there exists an element in A that is greater than the supremum of A minus this epsilon, which is epsilon divided by 2. The same we can do for the set B and get an element B that is greater than SB minus epsilon divided by 2. Therefore, if we add A and B together, we get something that is greater than SA plus SB minus epsilon. Or in other words, we found an element of A plus B inside the step of size epsilon from the left side of SA plus SB, which means by the epsilon property that SA plus SB is actually the supremum of A plus B.